introduction to Precomputed Visibility, I'm going to be covering some of the basics of Precomputed, such as how to set up Precomputed from scratch and how to adjust its properties to fit your game. Okay, as you can see, I've got Epic Citadel running. This is a really good example of showing you how Precomputed works and what kind of benefits you can get from using it. First of all, you just want to set up your viewport, so you've got two side-by-side windows, one of a wireframe, top-down preferably, and your perspective view. You can come to this arrow port here and make sure that view culling and occlusion is turned on. So that'll make sure that you can see the culling and occlusion that's happening in the viewport in real time. So as you can see here, I can see maybe 40 assets, for example. And as you can see in this viewport here, this shows all the assets that are currently visible. As I rotate around this viewport, you can see that different meshes are rendered, hidden and removed as I go. For example, if I go inside, there should be much less rendered. It means that at all times there's only a finite amount of meshes being rendered. As you can see there's a very little amount of meshes being rendered, which means that the performance in this area is going to be much better than if, for example, I disable it. The game will always be rendering every single one of these meshes at all times, whereas using Precomputed Visibility, you'll only be rendering a small section of the map. You can use this tool to make sure that you can visualize what's being rendered in your level at any one time. It can help you to adjust your volumes. As you can see here, the Precomputed volumes, you can adjust these until you find the sweet spot so that you're rendering the meshes you want without getting any pop in, but you're also getting the maximum performance possible. Okay, now we know how Precomputed works, we can move on to setting up. I've got a test level here, just a basic level with these walls which define the playable area. As the first thing you want to do before setting up Precomputed is define where your player can navigate and what the playable area is. In this case, this area here is going to be where the player can get and where cameras can navigate through. The areas around it aren't going to be used. So for Precomputed, all we're going to want to do is define this area to put cells in. If we were to fill, for example, this volume with Precomputed cells, it would be a pretty large waste of performance, as there'd be all these cells here being rendered for no purpose, as they'd never be reached. So we're going to move to our builder brush and bring it down to our level. What we could do is we could just have one volume like this that covers the whole area that we're after in one volume. That would be fine. We will get volumes here which aren't necessary, so what we can do instead is we can just create one volume by going to volumes, right click, Precomputed Visibility volume, create one there, and then move this along. And create one there as well. Just fit this to fit the walls. Something like that. Make another volume there. You want to make sure that your volumes are slightly above the floor. Okay, so what we have there, just get rid of the builder brush, is we've got one volume covering this area of that corridor, one volume covering the main area. You can have as many volumes as you like and as you need. Okay, once that's done, we need to make sure that Precomputed is enabled by going to View, World Properties. This checkbox here will be unticked when you get to it, so make sure that this is ticked. Place cells on the surface, that should already be ticked, but what this will do is it'll make sure that the cells are placed above this volume. If you untick this box, the cells will be placed inside of the volume, so it's a preference as to which one you'd like to use. The visibility cell size is how large the cells are that are calculated, and I'll show you that in a little more detail in a minute. Okay, once that's ticked, we're going to generate our cells. First of all, we're going to have to go to Build Lighting and make sure Use Light Mass is enabled. This is because light mass is needed to generate Precomputed. You've also got to bear in mind that Precomputed Visibility will increase your light mass build times as your levels get larger, and the more cells you render, the longer it will take to render your level. Okay, with your lights built, you might think there's no change, but your cells have been created. You just need to come down to the bottom left here in the console and type Show Precomputed Visibility, press enter, and there you go. There's your pre-computed cells. As you can see, it's also created cells for this camera automatically. So you also have to keep that in mind when creating your level. For example, if this camera was started here, I would need to make sure there's a strip or at least some form of volume covering this area so that the camera is covered by the pre-computed volumes. Otherwise, when the camera is here, the entire level would be rendered, which isn't always ideal. We're basically initially going to check for any gaps in the cells, so we need to make sure that each edge is covered. This is because if the player was to leave one of these cells, as I mentioned before, the entire level would be rendered. It's something you can come back to View World Properties, come down to your visibility cell size, and you can increase this if necessary or decrease it. I'll show you what happens if you increase it to a large amount. Increasing it to a large amount will improve your build times or speed them up, but I'll show you now why it's not always a good idea. As you can see, the cells are a lot larger now. It does mean that we're starting to get small gaps like this, and this is not what we want. So we need to make sure that the cell size is quite high so that your build times are relatively low and the performance is quite good, because every cell that's rendered costs performance, so the least cells you can get, the better. So it's a balancing act really of trying to find the perfect value. In that way you don't have any gaps and the performance stays where you'd like it. It's something you're going to have to test as you go. Okay, something like that might be better. In this case, these height volumes are set up for UT in a tournament game. Let's make sure my game type is set correctly. I'm just going to run the game. If we load the game up, press tab and type in Precomputed Visibility. As you can see, the cells are a little bit higher than the player model, which means I can never leave these cells, and there's no gaps that will allow me to leave. If I type in, press tab again, stat init views, that will show us some stats, some pre-computed related ones. The processed primitives shows me how many primitives have been calculated in the scene. We've got 44. And the frustum called primitives is how many currently primitives are being called. As I come down here, it should increase slightly as more of the scene is deleted. And as I turn around to reveal more meshes, it lowers. That shows you the performance increases that can be had, because as you come into less populated areas, you'll be saving performance by culling these meshes here. The benefit to pre-computed over standard culling is there's no popping. It's a relatively fast procedure, so you shouldn't notice any popping when using pre-computed. This means that your level will look seamless while still keeping the performance up. Okay, so that's a quick introduction to pre-computed. I hope it's helped. Thanks for watching.